So, in this session we are going to learn about modulation and its need, then amplitude modulation and how to produce amplitude modulated wave and how to demodulate the carrier wave. So, let us first see what is modulation. So, modulation, it is generally we do not transmit the raw information or the signal, that is called the baseband signal. So, baseband signal is generally mixed up with a high frequency carrier wave, and the process of mixing that high frequency carrier wave is called modulation. So, the baseband signal, that is the raw information that is collected by the help of transducer. So, the baseband signal, that is raw information, is mixed with high frequency carrier wave. The baseband signal is mixed with high frequency carrier wave, and this process is known as modulation. So, the mixing of the raw information, electrical form of the raw information, that we call baseband signal, with the carrier frequency, high carrier frequency, is called modulation. So, before transmitting, this modulation has been done. The modulation is done. The modulation is done before transmitting the signal through the transmitter. So, now let us see why this modulation is required. The need for modulation. What is the requirement of modulation? Why we can't send or transmit the baseband signal directly? Let us see. So, there are 3 points. We will see. One is the size of antenna. So, one is the size of antenna, and second point is the effective power radiated. And the third point is interference. So, these 3 points, because of these 3 points, we cannot send the raw information directly. We have to modify it with a high frequency carrier wave. Let us see it. Now, the size of antenna. How much size of antenna we require to transmit a signal will depend on the wavelength. Suppose this is the wavelength of light or wavelength of any wave. This is lambda. Now, this is lambda by 2 and this length is lambda by 4. Now, you see, if I am able to generate this part, then by taking its mirror image, I can construct this part, and taking its mirror image further here, by inverting it, I can reconnect, we can find this wave. That means the antenna, minimum size of antenna, the length of antenna should be the order of lambda, that is lambda by 4. So the minimum size of the antenna should be of the order of lambda by 4. Now suppose we have to transmit a speech, the humans can hear sound of frequency from 20 hertz to 20,000 hertz. So now let us see what is the order of lambda required. So let us see first 20,000. So if we have to transmit this wave 20,000 hertz frequency, lambda is equal to C by nu. Now we are not going to transfer this as a longitudinal wave. We want to transfer this signal in the form of electromagnetic wave. We are using C, light, that is 3 into 10 to the power 8 meter per second, and the frequency is suppose 20,000. So this is 1.5 into 10 to the power, this is 4 meters. 1.5 into 10 to the power 4 meters. That is 15 kilometer. 15 kilometer long antenna will be required. So if we have to transmit the baseband signal directly in the form of electromagnetic wave, we require large antennas. That is why what we do, we mix up this signal with a carrier frequency of some megahertz, high frequency, and then that is transmitted, so for which the lambda requirement will be less. So it is the size of antenna which decides, that is why, which limits our transmission of baseband signals. Now in order to transmit a signal, we require an antenna. The minimum size of the antenna to transmit a signal is of the order of lambda by 4. So thus we choose a higher frequency carrier wave for modulation, which utilizes a smaller size antenna. Now let us see the effective power radiated by an antenna. The theoretical studies of the power radiated by an antenna, linear antenna predicts power radiated is proportional to L by lambda whole square, proportional to L by lambda whole square. So the theoretical formula for the power radiated by a linear antenna is found to be L by lambda whole square. So if higher the lambda value, then lesser will be the power radiated. So if lambda is higher, then the power radiated is less. Power radiated is less. So, if we select a lower value of lambda, the effective power radiated will be high. So, thus a lower value of lambda is selected to increase the effective power radiated by antenna. Now, when we do modulation, we increase the frequency of the baseband signal, and increasing the frequency lowers the value of lambda, and so the effective power radiated becomes large. That is why we use antenna, and that is why we require a modulation. Now, the third point, this was the second point, and the third point was interference. Interference. Now, interference from other baseband signals. So, you see what happens. Suppose we have to transmit some speech. Speech means, generally speech involves a frequency of nearly 2000 to 3000 Hz. That is the frequency for telephony. Now, if I directly transmit this frequency, then what will happen? Then other stations are also transferring their speech. So, different people are transferring their different speeches, and all will have a frequency within this range. So, all will mix up, and this will be called interference, and then the whole signal will become simply a noise, and so it is not possible. Now, what we do next? We have allotted different frequencies to different stations. Suppose somebody is transferring speech from one place which is using 1 megahertz, another body is using 2 megahertz, another is using 3 megahertz. So, different bands and frequencies are allotted to different stations, so that all the signals, the frequency of all the signals will not overlap. So, that is why we modulate our signal wave with a high frequency carrier wave, and then we transmit it. So, before the power transmission takes place, we have to modulate my signal wave. This process is called modulation, and now let us see what is amplitude modulation. So, now let us see what is amplitude modulation. This is a high frequency carrier wave. This is denoted by CT. Its frequency is very high, and you see this amplitude is AM. And this is my modulating signal M, modulating signal M, that is a function of T. Here I have seen it's to be something as sine wave, but actually it's a complex wave combination. So, when we speak a complex wave with a frequency not constant but varying frequency will be there. So, let us suppose this. Now, this is the carrier wave which is modulated, that is modulated carrier wave. So, in amplitude modulation what we do, this carrier wave, the amplitude of this carrier wave is modified according to the instantaneous amplitude of this modulating signal. So, you see here this carrier wave and this frequency, you can see I have tried to draw the same frequency. So, what we do, you see this, the envelope, that is the amplitude of this carrier wave gets modified. You see here signal is more, so here more modification is there. So, here the signal is less, here minus, amplitude is minus, so this amplitude is decreased to 0. So, when the amplitude of this carrier wave is modified according to my signal instantaneous value of the signal amplitude, then that will be called amplitude modulation. So, the envelope of this modulated carrier wave represents the signal wave. So, this diagram is very important. So, in amplitude modulation, the amplitude of the carrier wave is modified according to the instantaneous amplitude of the signal wave. The modulated carrier wave, the envelope of the modulated carrier wave contains the signal wave. This is what we do in amplitude modulation. So, consider a carrier wave CT as a carrier. AC is the amplitude of carrier wave, sine omega CT. So, suppose this is my carrier wave and a modulating signal wave as MT as A modulation sine omega modulating into T. So, this is the standard terminologies we will follow to denote carrier wave function, and this is modulating wave functions. So, this is the amplitude modulation where the amplitude of the carrier wave is modified according to the modulating signal. Modulated carrier wave, this is modulated carrier wave. You see, the amplitude part will be written here and this is sine part omega carrier T. So, the carrier wave was previously I have wrote carrier wave as CT is equal to AC sine omega carrier this. So, this part is here and this part is modified. So, how I modified? This carrier wave is AM sine omega MT. So, this is what we do in this amplitude modulation. So, the carrier wave amplitude, this part is modified, mixed up with this modulating signal to get this modulated carrier wave. So, now let us simplify it. This is AC, we can take common, we will get 1 plus AM by AC sine omega MT sine omega CT. This is AC sine omega CT plus this is again AC times. So, now let us introduce a quantity called mu. So, mu times AC sine omega MT into sine omega CT, where mu is AM by AC. is called modulation index. Modulation index. Mu is equal to AM by AC is called modulation index. So now let us see what is this CM, that is the modulated carrier wave. This AC sin omega CT plus, you see we can take mu AC by 2 and then we will have this 2 sin C sin D. We will use the formula as 2 sin A sin B as cos A minus B minus cos A plus B. So this is the trigonometric identity we are going to use. So we will get cos omega C minus omega M T minus cos omega C plus omega M T. So we thus you see we got AC sin omega C T plus mu times AC by 2 cos omega C minus omega M T minus mu times AC by 2 cos omega C plus omega M T. So now what we see, the modulated carrier wave has 3 terms, three oscillating terms, one with frequency omega C, another with omega C minus omega M and another with omega C plus omega M. So the modulated carrier wave apart from the carrier frequency contains 2 side bands. This is the lower band, this is the upper band. So 2 side bands will be there apart from this. So now let us plot the frequency spectrum of the modulated carrier wave. Here this is omega and here we are plotting the amplitude part. Amplitude. So the amplitude is AC for the carrier wave. So this carrier wave, the frequency of the carrier wave is omega C. So in the amplitude modulated carrier wave, the carrier wave will have the amplitude AC and then next will be, this will have modulating index mu AC by 2 and it will have the lower side band omega C minus omega M and this is omega C plus omega M, this is the higher side band. So we have, apart from this frequency, we have 2 other bands. So this frequency and the total will be the bandwidth of the signal. Bandwidth. So thus when we transmit my signal wave with a carrier wave, then suppose this is transmitted at 1 megahertz and I am transferring my speech. So that means, so 1 megahertz, that means I will get a bandwidth with a lower and a higher frequency. So the transmitted wave will have a bandwidth. This will be the bandwidth. So this is the lower band, this is the higher band. So this is the frequency spectrum of a modulated wave. This is the frequency spectrum of a amplitude modulated wave. This is important. This is amplitude modulated wave. This is called AM. We have other modulations also, AM, FM, amplitude modulation. In FM, the frequency of the signal is modified according to the instantaneous value of the modulating signal, that is called FM. Then other modulation is phase shift modulation, the phase of the carrier wave is modified. So for digital, that pulse duration modulation and other modulations are also there. Presently we will see the amplitude modulation only. So now let us see how to produce amplitude modulated wave. So here we will just see the schematic, not the whole circuit diagram. So there are many ways to produce modulated amplitude modulated wave, but this is a schematic diagram to produce that, one of the schematic diagram. So first what we do is we add up my carrier wave. So this is carrier wave, this is C as a function of t, that is written as Ct is equal to AC sin omega Ct. This is my carrier wave. So here I have a adder, that is we are going to superimpose this carrier wave with my modulating signal. This is MT, that is modulating signal MT as AM sin omega MT. So from this root I am giving the signal wave, and from this root I am giving the carrier wave, and I am mixing. So here mixing means superposition. So we superimpose these two waves to get a XT. So after superimposing we get XT. Now XT is fed up into a device which is called square law device. So what it does, whatever is the input, its square function, its parabolic function, that function will be squared and it will be sent. That means here the output will be a parabolic function type. So what that is the quadratic function of xt, that is yt. So we will get yt as b times xt plus c times x as a function of t whole square. So you see this is the quadratic function, So the square law device just gives a quadratic function. Now this quadratic function is passed through a band pass filter which is centered at omega c. So this is a filter circuit. So it is centered at omega c, means omega c is the frequency of the carrier wave. So somewhat lesser than the carrier frequency and somewhat more than the carrier frequency, there are some side bands which is present in amplitude modulation. They will be filtered, and higher bands and lower bands will be filtered another way. That means they will be stopped and other will be passed. So what we know, that all the omega c and the sideband omega c minus omega m and omega c plus omega m, these side bands, these three frequencies will be passed, and that is what the amplitude modulated wave is. This is the schematic diagram of what we do in amplitude modulation. So first, so what are the stages involved? So first, the carrier wave and the signal wave is superimposed to get xt. So xt is the superimposition of these two waves. So next step, the wave xt is passed through a square law device to get yt, that is equal to b times xt plus Cx square t, and then Yt is passed through a band pass filter. You see, band means because it's not selectively passing omega c, the whole band is passed. So it is band pass filter which retrieves the amplitude modulated wave. Now this wave is sent to transmitter for transmission, and this is how my signal wave mixed with carrier wave is transmitted to the transmitting channel. Let us see what is xt. Xt is the direct superposition of this carrier wave and modulated wave. So this is mt, a modulation, sine omega modulating t, plus a carrier sine omega carrier t. So xt is the direct superposition of the modulating signal and the carrier wave. So now it is passed through a square law device. So the square law device, that is square law device, this gives yt as b times xt plus c times xt function whole square. So we will get yt as b times this, so whole term. So this is b times am sine omega mt plus b times this ac sine omega ct plus, so this is this part completed. Now this part, this c part, so this is c times square of this, the square of a square plus b square 2ab. So first of this square, c times am, c times square of this, so am square sine square omega mt plus c times this square function. So this is ac square sine square omega ct, and then it's 2ab term, then 2c amac sine omega mt into sine omega ct. So now yt is equal to, you see these two terms, let it be here bam sine omega mt plus b times ac sine omega ct plus, now this is sine square term. So we use the formula that cos 2 theta is 1 minus 2 sine square theta. So if we have sine square theta, that 1 minus cos 2 theta by 2 we will write. So simply here this is sine square theta. So we will write this as cam square by 2 1 minus cos 2. So we can simply write this as this minus cam square by 2 cos 2 omega mt. So this is replaced by this term plus, you see here is one more similar term. So here only I will write that is CAC square by 2 minus CAC square by 2. Then this is again cos 2 omega, this is M and this is C, omega CT. So we got these two. Now come to this term. So here now I am using a formula, trigonometric formula, 2 sin A sin B as cos A minus B minus cos A plus B. So this formula I am going to use for this. So we will get C times AMAC cos A minus B. So you see here this minus this, so we will write cos omega C minus omega MT minus CAMAC, then again cos omega C plus omega M into T. So you see here this is YT, the whole term is YT. So this YT is now YT is passed through band pass filter, band pass filtered centered at omega C. So what will be passed? So you see this term has a frequency omega C plus omega M. For modulated wave, this was my higher band, sideband. This was my lower sideband for the amplitude modulation. And you see this term is omega M, omega C, this term is omega C. So what this band pass filter will do, it will pass omega C minus omega M, omega C plus omega M. What it will stop? Omega modulating signal. This signal has a lower frequency. You see, we have increased the frequency by using a carrier wave. So lower frequency, this will be stopped. This is the DC part that will be stopped. This is the DC part that will be stopped. This is omega M, 2 times omega M is also small, and 2 omega C is very high. So these will be stopped. So now YT is passed through the band pass filter centered at is omega C, which stops the DC parts. DC parts means this one is the DC part and this is the DC part. DC parts and the lower frequencies. What are the lower frequencies? Omega M and 2 omega M. And the higher frequencies. And the higher frequencies C's, which frequencies? So this part will be also rejected, 2 omega C. What it will pass? Now the frequencies selected are omega C minus omega M and omega C plus omega M. The whole the center frequencies, lower sideband, upper sideband, these are present amplitude modulated wave, and this will be passed. Now let us see how to demodulate or detection of amplitude modulated wave. Actually it is demodulation of amplitude modulated wave. So what we do, the amplitude modulated wave, that is what is the carrier wave, modulated carrier wave, when we are going at the receiver end, is passed through a rectifier. This is the rectifier, and you see this rectifier, this is the input, the amplitude modulated input wave. So here you see the amplitude is varying like this, and this is the frequency of the carrier wave. Now this is passed through a rectifier. Rectifier is a device which converts AC into DC. That means it removes this part and thus it just rectifies and places this part. Now this is given input to a envelope detector. So this envelope detector just retrieves this envelope by passing through a RC circuit. So we finally get this signal, that is the signal, initially the signal we have given this signal. So in this way the signal is retrieved from the modulated carrier wave. This is the schematic diagram of this. So the modulated, the process of retrieving the message signal from the modulated carrier wave is called demodulation. So you see, when we watch a program in our TV, the TV antenna catches the modulated carrier wave and then it retrieves the signal by this mechanism, and then that signal is given to the output device, that is the cathode ray tube or the screen of that system. So this process is called demodulation. The input is at stage A. At stage A contains omega c and omega c plus minus omega m frequencies, which is passed through a rectifier and thereafter to an envelope detector, that is actually RC circuit detector, which thus the signal is retrieved in stage C, which is sent to the output device for the user. So thus the user gets finally the output signal. This is the schematic way of doing this demodulation, that is retrieving the signal from the amplitude modulated carrier wave.